I get this question quite often. Do I need to code as a DevOps engineer? The answer is not necessarily, but a better answer is 1. Understanding the strengths and weaknesses of a programming language. Number 2, knowing how to read basic code. And number 3, being able to tell whether code is written inefficiently will make you a far better engineer than someone who doesn't. Do you need to know a lot of this coding stuff to be good? Probably not. Do you need to know some of this programming stuff to be great? It will help you a ton. Understanding how to write basic code will help you write your own tools. It'll help you extend your existing platform beyond its capabilities. It'll also help you understand the fundamentals of the developer workflow and helps you improve developer agility. Today we're going to be taking a look at an introduction to the Go programming language, and we're going to be taking a look at all the fundamentals to help you learn how to write Go. Now we have a lot to learn, so without further ado, let's go. So if we take a look at my GitHub repo, I have a Golang folder, and in the Golang folder I have an introduction folder with a README. And in this README I have all the steps that I'm going to be showing you guys today. So be sure to check out the link down below to the source code so you can follow along. Now the first thing we need to do is install the Go programming language. Now if you head over to golang.org, you can find all the installation instructions here, so you can go ahead and download Go for different operating system distributions. This will take you over to the downloads page where you can go ahead and select the download you wish to install. So you have Windows, Mac OS, Linux, or you can download the source code. Go is also very well documented, so you can head over to the documents section and then look at the getting started section. They have an installation instruction guide as well as a tutorial for getting started. So if we head over to installing Go, you can find separate instructions for each operating system on how to install the Golang programming language. And once you've installed it, you can head over to your terminal and type Go version, and this will print out the installed version of Go. So to test your Go installation, you can go ahead and type Go version, and this will print out the installed version of Go. You can see if I run Go locally, I don't have Go installed at all. This is because in this tutorial I'm going to be doing something slightly different. I'm going to be running Go in a Docker container. As a DevOps engineer, bringing Docker into your development workflow can have a lot of benefits. Since we'll be working in a container, this can almost guarantee that what we're building is going to be very similar to production, since we'll be running a container in production. It also keeps our system clean because we don't have to be running and managing multiple versions of Go and all the dependencies. So the first thing I'm going to be doing is changing directory to this Golang introduction folder. I change directory, and in that directory I have a Docker file, as you can see here. You can also see it on the left here. And in that Docker file, I simply say from Golang 1.15 as dev, and then I specify a working directory. So I'll be doing all my work in a folder inside of the container called /work. This makes things very simple. I also add a target here, basically providing an alias for this Docker container called dev. And this will be representing my development container. Later in this video, I'll showcase how we'll have multiple targets, such as the build target and the runtime target. So we can go ahead and run the build pipeline inside of the container as well as producing a runtime image that we can ship to production. Now remember, I have all this instructions in the README. So to go ahead and build this container after I've changed directory, I can say docker build, and I can provide the target dev, and then I say dot because I'm already in that folder. That's the folder where the Docker file is located, and then I tag this image as Go, and you can tag it as anything you like. So I go ahead and copy that and paste it to the terminal, and that'll build our container image that we'll use as our development environment. And then to run the image, I can say docker run -it because I want an interactive terminal so that I can work inside of the container. I also add a volume mount, which is my working directory. That's the working directory that we're currently in. And then I mount it into that working folder in the container /work. And then I indicate the container image I want to run, which is called Go. That's the one I tagged earlier. And then I specify the entry point, which is sh, which is just the shell terminal. So I go ahead and copy that. I paste it to the terminal, and that will give me a container where I can go ahead and do my work. If I do ls, we can see we have the Docker file and the README. So we're pretty much in this directory on the left hand side here, and I'm in the container. I can go ahead and clear that terminal and I can say go version, and we can see we have go version 1.15 installed. So now in my terminal, I'm running a container with Golang installed. I can see my code via Docker volume mount, and I'm able to use Go as if it's installed on my machine. So the first thing is that it's very important to understand how to structure our projects in Go. That's our folder structure as well as our files. Packages allow us to group multiple Go files in a folder in the same directory and compile them together as a package. All the Go files that are part of the same package have visibility of all functions, types, and variables. And modules are a collection of packages that are released together. And a repository can contain one or more Go modules, but usually just contains one at the root of the repo. In this video, we'll have a repository. We'll create a Go module that may hold a few packages, but in this video we'll have one package called main. And in this package we can have multiple Go files. We'll have two Go files, one called app.go, which is the starting point of our application, and another called customers.go that holds some code for dealing with customers. These Go files can share things like functions, variables, and types because they're all part of the same package. In addition to this, we can have a Go mod file which lists our module definition, as well as other modules that our code may depend on. And just another reminder that all of this code structure stuff about packages and modules and repositories are all documented in this README. But to get a better understanding of all of this, let's write our first program. So I have instructions here to write our first program. So the first thing we're going to do is create a folder called app. So at the root of our repo, and this folder is going to become our repository. So I say mkdir app, and we can do ls. We can see we now have a folder called app, and I can change directory into app. And the next thing I'm going to do is define our Go module. And to do this, I'm going to say go mod init, and then the link or the name of our module. So I go ahead and run that, and that'll go ahead and create a new Go mod file that's the module definition for the module we're writing. So if I look in the app folder, we now have a go.mod file. This is the module definition. We can see we have a module with the name of our module as well as the version of Go that we're writing in. One thing to notice is that our module can be a link to a GitHub repo. This is because if we wanted to, we could write modules that other people can use. We can also reference other people's modules by running the go get command. This will download those external modules locally and add them to our go.mod file. This go.mod file is basically where our project tracks dependencies. So we'll see our module definition as well as other modules we may be referencing. Now in this video, we're only going to be taking a look at our local module that we'll be writing, but in a future video, we'll take a look at how to reference external modules. The next step I'm going to do is write some application code. So in my app folder, I'm going to right click, I'm going to create a new file called app.go, and this will be our main entry point for our application. And in our README, we can see that we have a basic application here. I'm just going to go ahead and copy this, and I'm going to paste it into app.go. And this is the most basic starting point for an application. Now, as I said earlier, all the source code is part of a package, and we can have multiple packages. So in this example, I'm going to have a package called main. This means that any other Go files that I create will have access to functions, types, and variables if they belong to the same package, which is very useful, and we'll take a look at that in a second. The next thing I do here is I import a library, and in this case I import the FMT library. The FMT package is a standard package with the Go programming language that allows us to write stuff to the terminal. And next up here I have a function called main. This function will be the entry point of our application and will be triggered when we run our application. And the only thing we're doing in this application is saying FMT using that standard module. We're calling a function called println, which basically writes any string to the terminal. And here in this string, we pass it a string called hello world. Now we can run our code by calling the go run command. So I say go run app.go. This will go ahead behind the scenes, compile and build the application and run it for us. So I go ahead and do that, and we can see all it's doing is printing hello world to the terminal. So not very useful, but it's a starting point. It's important to know how to run and build code. code in Go. So that's how you run code. To build the code, I can say go build, and that'll automatically go and build it. And on the left-hand side, you can see it produced a binary called app. We can then go ahead and run that binary by saying /app, just like we run any arbitrary Linux binary. And if we do that, we can see it also prints out hello world. And in Linux, you can give this chmod execution rights and you can move it to user local bin and it'll behave like any other CLI. If you compile for Windows, you'll get an app.exe, which you can move to your path and you can use it again like any CLI. The other cool thing Go allows us to do is to say go install and then install our module. This will install the binary into our home Go bin app folder, or under Windows it'll go to our user profile /go bin app.exe. If I go ahead and run that, I can change directory now to any arbitrary folder and I can just type app. And we can see our application is installed inside of this container and I can run it without having to find the binary. Just like any CLI like kubectl or Docker, I can just run my application in the command line. So very useful if you want to build a command line interface. So now that we have a basic project structure and an understanding of modules and packages, and we have our basic app.go, a critical building block of coding is how to write functions. Functions allow us to execute blocks of code. Now you want to always aim to give your functions a single purpose. You can run a function without any inputs, or you can give a function inputs and receive outputs. Well thought out functions makes it really easy to test our code. So always have a good think about what functions you want to create and what you need. Now, instead of just making a boring function that adds two numbers together and returns the result, let's do something simple but a little bit more realistic. And as we progress through the series and we learn more, we'll move to more advanced, more realistic examples. Now, in my example here, I have a function. So I'm going to go ahead and copy this function and paste it into our app.go file. Remember, we can create multiple functions in here. So I'm going to create this function called getData, and the purpose of this function is to get us some data. It's important to understand that we can have inputs in a function. These are things we want to pass to the function, and we can have outputs, and these are things that we want to get from the function, which is going to be our data. Now, the idea of these functions is that they are pretty modular. The function knows how to get data, whether it gets it from a file, from a database, from a Redis cache. It doesn't really matter. The person who calls the function should not have to care about how to connect to Redis or how to get the data. They simply call the function, pass the inputs, and get the outputs, which is the data. Now, a function does not have to take inputs. We can remove the inputs and just say get data and get some outputs. A function does not have to return any output either. If you don't want to return any output, you can simply take that out and just do it like this, get data, and you can pass input as well. So it is very flexible. So let's move to something a little bit more realistic, which is a function called getData, and we're going to pass in a customer ID. So we can pass in a customer ID and we want to get some data about this customer. And then this function will also return our customer in a variable. So this is very simple. I define a getData function. I pass in a customer ID of type integer because the customer ID is a number. And then I'm expecting some customer data back in form of a string. So this is just like some text field that I want to return. But it's also important that our function makes sense. We want to keep our function modular so that if we look at the function name, we know exactly what to expect from that function. Kind of like if we had a car, we would want an accelerate function, a decelerate function, turn left function, a turn right function. If we're managing customers in a database, we may want an add customer, delete customer, update customer function. Now, it's important to notice that these inputs and outputs for our functions are variables, and inputs and outputs in functions are always defined by the name of the variable and then the type. So you can see we have customer ID as the variable coming in, and it's type integer, which is a number, and then we have a variable called customer, which is the output, which is of type string. So this is just random arbitrary text that it can return. It's important to note also that there are a number of different types in Go. There's bool, which is boolean, like true and false. This is good for decision making. We also have string, which is just arbitrary text. We then have integer numbers, which start at int. Then you have int 8, 16, 32, 64. These are different sizes of integers. Because numbers can be anywhere from 0 to a maximum amount of numbers, they're all different sizes. Then we have a little bit more complex types such as byte, root, string, float 32, and complex 64, which we'll take a look at later in the series. It's also important to notice that I can write any code inside getData to return. So I can connect to a database to return some customers from a database. I can look at a Redis cache. I can look at a local file. It doesn't really matter. Later in this Go programming series, we'll take a look at how to connect to caches and databases. But for now, let's just return some customer data. Now, to hold data in a programming language, we use variables. Variables are just placeholders in memory that allows us to store data. The more variables we create, the more memory we may use. The larger the data inside of these variables, the more memory we use as well. Now, although we can store quite a lot in memory, we want to be efficient about it, and we want to try to keep it minimal. So I've already mentioned that we can have variables as inputs and variables as outputs, but similarly we can create variables as local variables inside functions. So to give you an example, I can have a variable called first name, and I can set that to a string. Strings have quotes around them, as you can see here. Also, I define this variable by saying var. Now, the Go programming language is smart enough to look at this variable and go, okay, this is a string. When variables are created, they have to be initialized first. That's why we put var in front. This will initialize the variable and then we can go ahead and use it. We can also initialize another variable called last name, and we can do it slightly differently. This time we can leave out the var and we can use this character in front of the equal sign. This will tell Go to instantiate or initialize this variable called last name, and because we have quotes around it as a string, Go is also smart enough to know that this is a string variable. I can also define an empty variable by saying var full name and just define it as type string. This will initialize a variable called full name, which will be an empty string. Now, this full name variable here might not be useful. To create the full name, I can also concatenate strings, so strings can be joined together. So to do that, I can actually go full name and I can instantiate it with this character and then say first name plus a space plus last name. This will concatenate the first name and the last name together. It's important to know that in Go, if you declare variables, you have to use them, otherwise you'll get an error. Also, if we define a function that expects some output, we have to return an output string. In this case, it is a string. So what I can do is I can just return full name. Now let's go ahead and invoke our function. So what I'm going to do is in the main function, I'm going to get rid of this hello world, and I'm going to say customer, create a new variable for my customer. I'm going to call my getData function. I'm going to pass in a customer ID, and then what I'm going to do is I'm going to say fmt.println, and I'm simply going to take my customer and print it to the screen. So what this will do is this is going to call the getData function, pass in an ID that we're not using at the moment. This is going to go ahead and call our function, which is going to declare a first name, a last name, concatenate that as a full name and return it. And the next line here is going to use the FMT library to print it to the screen. If I go and run that, I can say go run app.go, and we can see we've printed our customer to the screen. So this showcases how to invoke a basic function, pass inputs and outputs. Now what we've covered here is variables, so how to define variables that are local to functions. It's important to know that these variables are only available to the code inside of this function, so I cannot reference those variables from other functions. In order to do that, I need to instantiate global variables. Global variables are instantiated outside of the functions. So I can go outside of my function and I can say var test equals blah. This will define a variable of type string with the contents blah that's global to our application. So we can refer to this variable called test in any function and in any Go file that has part of the package main. So to test that, I can create another FMT print. I can pass in test over here, and I can copy this command and paste it into our other function as well. And if I say go run app.go, we can see that we have blah twice. That's because we've accessed the variable from our main function as well as from our getData function. Global variables are really good for sharing data across multiple Go files that are part of the same package. Now, a real use case of this would be a database connection client. The database connection client will hold things like the connection string, the address and port of our database, as well as the credentials, and we can define that client as a global variable, and this client global variable can then be reused across our entire package package to access a database. So stick around for this Go programming series, as we'll definitely take a look at that as well. Now it's important to note that there's some optimizations that we can do here. Instead of defining all these variables, we can do things slightly differently. Firstly, we don't have to define a variable called full name, do the concatenation, and then return it. We can simply take this return statement, put it in front of this guy, get rid of this return statement, and we can get rid of this full name variable initialization, and we can simply say return first name plus space plus last name. This will basically return the full name computation and prevent us from having to define a full name variable. So we can keep our variables to a minimum. Or we can take it to the next level and say we don't want to define a first name or a last name, and we can simply say return and return the full name. This just goes to show that we can be smart about how many variables we need to instantiate, and we don't need to instantiate variables for everything. Control flows are the foundation of business logic in our code. This is where we can say if this, do that, else if that, do this, else do something else. Control flows are decision trees that we can define to add business logic to our code and make decisions. Now you're probably looking at this function and you're probably thinking, why am I not using the customer ID coming in? That's because you're right, we're not using the customer ID at the moment. Now we can use this customer ID by defining control flow. Control flows allows us to add business logic to our code, so we can add if-else statements. So if we take a look at our README, I've got this all documented here. Now let's take a look at this control flow. So we say if customer ID equals 1, return this customer. Else if customer equals 2, return that customer, else return an empty string. So that's very basic. We can just build decision trees and add logic to our code. And we can run our code by saying go run app.go, and we can see we're returning the right customer. That's because we're passing in customer ID 1. I can also run this again by saying get data, and this time pass in the wrong customer ID and expect an empty string to come back. But also notice that a variable cannot be instantiated twice. So in this case, I have to remove this instantiation character, and this means that the customer will be instantiated over here. We'll get the data for customer 1 into this variable, we'll print it to screen, and then we'll override that variable with whatever this function returns, which is an empty customer, and print it to the screen. So this shows you that variables can be overridden as well. And if we run our application again, you can see it prints customer 1, and then it prints an empty string, which is customer 3, which is hitting this return empty statement over here. So that showcases a very simple if-else statement in Go. Now at the moment in our application, we're simply dealing with basic variables, and we can only return 2 customers at this stage, which is not really realistic. Although it showcases variables and is useful for understanding the foundation, it's not realistic for a real application. Now realistically, our application should be able to return more data dynamically, not just 2 customers. This is where arrays come in. Arrays allow us to have a collection of variables of the same type, so we can have a collection of strings, a collection of integers, and so forth. Now let's see how we can use arrays to return a list of customers. Now to make our function more useful and return an array of customers, we have to change our output that we have here. So instead of returning a customer as a string, we can change this to be customers, as we're going to be returning multiple customers, and we can change this to an array of type string. Arrays are defined with these brackets followed by a type. So now this customers will be an array, which is basically a collection of strings. Now the downside of an array is that it has to have a fixed size. So I have to give this array a size. So let's make it 2. And let's go ahead and remove this code, and let's instantiate our first record of a customer. So I instantiate my variable as we've done before, and let's go ahead and assign our customer to the array. And you can see we're using brackets here to assign it to the array. Arrays are indexed, so we have to specify which index of that array we want to assign our customer to. Because our customer's array only has 2 spaces, arrays always start at 0. So we can assign it either to index 0 or index 1. If we try to assign it to index 2 or 3 or 4, any number higher than 1, the index will be out of bounds and we'll get an error when we try to run the code. So it's important to understand this, that arrays have sizes. So in this demo, I'm just going to say customers at index 0, and I'm going to assign my customer to that location. invocation. Also remember, I don't have to create a brand new variable like this, so I can create another record and simply just add the string like this, which is a little bit more efficient. And then let's go ahead and return our customers. And for now, since we're not going to be using the ID, I'm just going to remove this input from our function, and we're going to change our invocation of the function. We're going to say customers, as we're expecting a list of customers, and I'm going to remove the ID that we pass in. So we're just going to say customers equals get data, and this will return an array of 2 customers. And then I also have to change my print line statement here to refer to the customers array. So it'll go ahead and print that to the screen. And if I say go run app.go, we can now see that we're printing 2 customers to the screen. We can also see the size of the array by running the len function. This is a built-in standard function in the Go programming language that we can use to print out array sizes. So I can say fmt println, and I can pass in the function here. I can say len open close bracket and pass in my array. If I go ahead and run that, we can see it prints out the size to the terminal. So this is useful to look at the size if you want to figure out how large the array is. Now, many people get confused between the differences of a slice versus an array. Now, the downside of an array is that it's fixed in size. When we initialize an array, we have to give it a size, which you saw in our customers demo. Now, as you saw earlier in our functions example, functions can take inputs and output. The other downside of an array is if we pass it to functions, Go will under the hood create a copy of the array. So the more we pass arrays down to functions, the more copies Go will create of these arrays, and this can use up a lot of memory. Now, slices make this much easier because a slice is an abstraction on top of an array, so it makes our lives of managing arrays easier. So instead of using an array, we can simply use a slice, and under the hood, Go will manage the array for us. Now, arrays are actually quite rare in Go, as most people use slices. The cool thing about slices is that they're not fixed size, and they dynamically expand when we add items to them. Also, when we pass slices around in functions, they're no longer copied in memory. So this means slices are much more flexible, making them more attractive than arrays. So let's take a look at slices. Now, because slices are dynamic in size, we can go ahead to our customers array here, and we can remove this size number. And it's important to note that this variable here is already instantiated. So this means we cannot say customers and pass in the instantiation character and set this guy to a slice of type string, because it's already instantiated up here. So what we need to do is we need to remove that instantiation character, and we can define an empty slice like this. And then what I can do is I can remove this code, and let's append some customers. I can do that by saying customers equals, and I can use the built-in Go function called append. The append function takes in a slice and the item we want to append to it. So in this case, I'm passing in my customer slice and I'm adding my customer to that slice, and then I go ahead and return it. Or even better than that, instead of appending my customer and defining an empty slice, I can define my slice with pre-filled items. So I can say customers equal a slice of type string, and I can use the curly brackets, and I can pass in a list of comma separated strings. So this shows you how you can define a slice with pre-filled items. And Go also allows us to append items to the slice by calling the append function I showed earlier. So let's add our legendary YouTube and Patreon engineers. So I can say customers equal, and I can call this function multiple times, as many times as I like, and I can append all my customers to the slice. And then I can go ahead and return the customers. And if I run this app, we can see it's printing out all our customers, and it's giving us the size of the slice, which is 10. Now in this video, you can see we've hard coded out 10 customers, which is not ideal. We can technically fetch these customers from a file, from a cache, from a database, or another service. This video is a fundamental building block of the series, so in a future video we'll expand on everything we've learned, so stay tuned. Now, loops are very important for using data structures. Loops help us iterate over collections like array and slices, so we can add crucial business logic for each of our customers. If there were some business logic checks we'd like to implement for each of the customers in our slice, we would use a loop to iterate over them and apply the logic to each customer. So in this video, we'll be taking a look at a basic for loop. So let's go ahead and add a loop to our function. And this is probably the most basics of loops, but if I write a for loop like this showcases a for loop that will loop forever. Now this is also called an infinite loop because it will loop forever. Now infinite loops might be useful to run some code periodically over an interval, especially for code that runs like batch jobs that maybe wants to do some calculations every 10 seconds or run every 5 minutes or every hour or once a day. Now writing a for loop like this might not be useful as it might just churn CPU. So what I would want to do is run some code periodically and then add a sleep in between. So to do this, I can import the time library. So to import multiple libraries, all we have to do is place brackets around these libraries, and we can format our input function like this. And then we can add multiple libraries. So I can add the time library as well. So the time package allows us to add a sleep function. So now in our for loop, we can go ahead and do two things. The first thing we're going to do is say fmt println, and we're going to say this is an infinite loop 1. And then we're also going to sleep by saying time.sleep. So this is the sleep function of the time package. And we're going to say that we want to sleep for a time.second. So this will sleep for 1 second and print out this message continuously. And if I say go run app.go, you can see that it's sleeping and every second printing out a message. So now what we can do is we can periodically run some logic every second. So this is useful if you want to write some control loop that does arbitrary code execution every X amount of seconds. Another statement that's useful to know with loops is the break statement. If I run the break statement, this will allow us to break out of the function. So this is useful if you want to loop for X amount of time until you find a specific record or until you meet some kind of criteria. And if we run our application now, we can see we started our infinite loop, but then we broke out of it after a second, and then we continued execution. So just something useful to know that you can break out of loops. Another useful thing with loops, instead of looping forever, is we can write a loop that loops X amount of time. So what I can do is I can replace this loop with another type of for loop. And in this for loop, you can see there are 3 components inside of this for statement that's separated by semicolons. So the first statement defines a variable called X. So we say X with the instantiation character equals 0. So we define a variable called X with a value of 0. And then we say if X is less than 10, then run the loop. And then every time you finished one execution of the loop, add a number to X. So increment X by 1. The plus plus statement is a very useful statement in Go which allows us to increment integer variables. So what will happen is first execution of this for loop, X will be instantiated at a value of 0. When this code runs, it will then after the execution increment the number and make X equal to 1. And then it will run again, increment X to 2 and continue. So basically this loop will run 10 times, and that's the exact number of customers that we have in our slice. It's important to notice that this type of loop will run a fixed amount of times, and the code that we add here is fmt println and print our customer in the X index. So remember our slice has a capacity, and at this point we know that our slice has a capacity of 10. So this loop will start by printing index 0, then index 1, then index 2, and it'll increment up to the max number, which would be 9. Because our slice is 0 indexed, it would start at 0 and go up to 9, which is 10 variables. And also because we've removed the reference to the time library, we have to go up and make sure we remove the time package from the import statement. Otherwise Go will complain that it's imported and not used. So this makes Go pretty efficient. I can then say go run app.go, and we can see our function is now looping over each customer and printing their names out to the screen before running this return statement, which returns all the customers to the calling function. Now it's important to know that our slice has a capacity of 10 customers. So if this array and this X number grows to a number that's outside of 0 and 9, our index will be out of range when we try to access the item in the array. So that means that this code is pretty limiting because it can only loop 10 times. So a smarter way to loop through slices is not to use a specific for loop like this. A for loop also allows us to loop items in a slice without specifying and incrementing an index. So we can replace this line with a for statement like this. So for loops have the capability to increment numbers automatically for you and not limited to a fixed number. So I can say for X, and we can call this X anything. People can sometimes call it C for counter, I for increment, we can call it X or A or Y, it doesn't really matter. The next variable we expect here is going to be our customer, which is the item in the slice. And we define this customer with this character, and we put the equal sign, and then we specify the range statement. So Go will basically loop through all of these items in the slice and return, for every item in the slice will return the object over here in this variable. This means that this logic will no longer execute 10 times, and it'll execute dynamically depending on how big our slice is. And this is quite useful because we still get the increment number, so we can still go ahead and access our customer by passing in that increment number into the index of that slice. So that means I can do something like this. I can say customer equals, and I can grab a customer out of the array using the index number provided by this for loop, and then I can pass that customer to the print statement. So if I say go run app.go, we can now see that our for loop is running and printing every customer to the screen. Or even better than that, if we don't want to use the X variable, we can silence it by replacing it with an underscore. And then we can remove this variable declaration over here and simply print out the customer directly. And if I say go run app.go, we can now see the same thing. So it prints out all the customers in that loop. One thing you've probably noticed so far is that a customer is not very useful as a string variable. Customers can have multiple properties like first name, last name, date of birth, and more. For this purpose, we'd like to group a bunch of variables as a single variable called a customer, similar to a database where you have one customer record that has many fields. Now in Go, this is what a struct allows us to do. So let's convert our customer to a struct. So to create a customer struct, what I'm going to do is I'm going to structure my code a little bit differently. I'm going to go into the app folder and I'm going to create a new file called customers.go. And in this file, I'm going to do everything related to customers. So I'm going to start by defining what package the source code belongs to, which is package main. This means that our app.go will be able to access all the functionality that we put inside of this Go file. Then I will define a struct like so. So the first thing we do is define the name of the type that we want to define. So in this case, I want to define a struct called customer, and then I'm telling Go that this customer is of type struct. So similarly, like how we define an int or a string, we have to tell Go what the type is, and then we define curly brackets, and we can add fields to the struct. So in this case, I'm saying first name is of type string, last name is type string, and full name, which is type string. And this gives you flexibility to build objects of your liking, and you can define any type of useful data structure. So rather than our previous get data function, which doesn't make much sense, let's create a get customers function in this customers.go. So what I'm going to do is I'm going to say func to declare a function, give it a name called get customers, and we don't need to pass in any input because we want to get all customers. And what we're going to do is the output that we return is a variable called customers, and it's a slice of type customer. So we're returning a slice of structs here, and that is our basic function. Now let's go ahead and see, how do we initialize a struct? If someone wants to use it and they want to define a customer, this is how we do it. Similarly to strings and int, we give it the name of the variable we want to use. I want to define a variable and I want to instantiate it with this character and assign it something. And the way we define a struct is by saying the struct name. So I say customer, and then I can open close brackets. So this would be an empty customer. Now we know what fields we may want to give this customer, so I can go ahead and fill it out inside here, separated by commas. So I can say the first name, and then I can pass in the string, and you can see I'm using a colon. So this is very similar to JSON notation. And then I put a comma because I want to add another field, and I just say last name. And you can see I can leave the full name out over here. So I can just define a customer like this. So this is my customer object that I've created now. Now let's go ahead and append this customer to our array. So what I can do is I can take this array and say equal, and then I can call the append function. And in the append function, we have to tell it what to append to. So we want to append to the same array or the same slice. And then I want to say comma, and then pass in our customer. This will go ahead and append this customer to this slice, just like we've done before. I can also pass in more than one customer. So I can pass in Bob and I can pass in John if I declared separate customers as separate variables. I can also define more customers in here dynamically. So similarly to how I created a variable up here as a struct, I can create a bunch of them and pass them in separated by commas. So I can do it like this. I can say customer, first name, last name, and I can define all of these customers separated by commas. And then last but not least, I have to return my customer by saying return customers. The other thing to know before we can use our customer struct is to surround this struct with a type declaration. So we're declaring a type here, letting Go know that we want to define these structs that can be used by other Go files in this package. So we simply surround our customer struct with the type declaration, open brackets, and close the brackets at the bottom. To test whether this works, I can just say Go build, and Go will complain if there's any syntax errors that we have to fix. Now let's go ahead and invoke this get customers function. So to do that, I head back to the app.go file. I go to my main function. Let's go ahead and remove the existing code that we have already, and let's define our customers slice, but this time we're going to initialize it from the result of this get customers function. And then just to make sure we're returning the right customers, what we want to do is we want to print out the customers using our for loop we did earlier. So we can say for silence the iteration number, give me a customer out of the range of the customers slice, and print them to the terminal using the FMT package. I can then say go build, and it's all building successfully. It's important to know now that we have multiple files, we can't just say go run app.go because we have to compile all of them to the same package. If we do this, we can see that our app.go cannot find the function called get customers. So we need to build our binary. So we say go build, that will produce a file called app that we can see here. And we simply say ./app, and we can see it's printing out all our customers now. So now we've learned how to write important data structures. We've learned all the fundamentals, how to write separate Go files and add our business logic to those Go files. So now that we've learned a lot of fundamentals, it's important not to stop there. Let's take the code that we've built and build up a container image that we can run in something like Kubernetes, and we can actually ship it to production. A Docker image allows us to have multiple layers. So far we have one Docker file with one target called dev. This gives us a little container that we can do all our development in. So it's useful for development. So let's go ahead and add a second target to that Docker file so we can add a build pipeline to the Docker file and actually run go build in the container image as well. And finally, let's add a third target which allows us to add a lightweight runtime image so we can build up a final image that we can ship to something like Kubernetes. So rather than compiling our Go binary for different operating systems, let's package it in a container, which makes it extremely portable and we can run it anywhere. So let's create another target to our Docker file. So you can see over here I'm saying from Go 1.15 as dev, set our working directory. This allows us to define a target called dev where we can just locally develop. This allows us to add debuggers to the container and things like that. If you want to know how to debug Golang in a container, check out my link down below to my debugging guide for Go. To build it, we can simply say from Golang 1.15 as build, so we create another target called build. We set the working directory to app, and then what we do is we use the copy statement and we copy all the files in this app folder that we have on the left here, copy that into the app directory in the container. And then we go ahead and we simply say run go build, and we produce a binary called app. Now this is good for a build pipeline, so we can actually run go build, and later on we can introduce go tests, and we can write unit tests as well. Now it's important to know when we go to production, we don't want the whole Go SDK installed in our container. So for that, we're going to make another target called the runtime. So I say from Alpine as runtime, and notice that we don't include the entire Golang image here. We're simply running on Alpine, which is a lightweight Linux distribution that's extremely small. It's only a few megabytes. And then what I do is I say copy from the build target, which is the target up here. I copy out the app binary from the app folder, and I copy it into /, so just into the root directory of this Alpine container image. And then to start up the application, I simply say cmd to run a command, and I run the app. So a very simple Docker file. So it's very important to understand the differences between the targets. So if you wanted to build and develop locally, you would simply say docker build -- target dev. This means that we'll only build the top 2 lines over here, and we can actually compile code inside the container. If I want to run the build step inside of a container, I can change directory to the Golang introduction folder, where the Docker file is located. And I can simply say docker build and pass in the build target. So this may run build and unit tests and things like that if you only want to run that. And then point to the Docker file, which is in the dot location, which is local, and then say -t and just tag it as customer app. So we go ahead and run that, and that will just go ahead and build the container that we can't really run yet. If we want to build the final layer that we want to ship to production, we can say docker build -- target runtime, or we can simply remove this since it's the last layer. So we can just say docker build dot -t and tag our image with customer app. So I go ahead and run that. That'll produce a container image without the Golang SDK, with our binary that we can go ahead and run somewhere. To run this container image, it's very simple. I say docker run and the name of the image, and we can see it's printing out all our customers. Very, very simple. So hopefully this video provides you the fundamentals of understanding the Go programming language and write your first application. Remember to check the link down below to the source code so you can follow along as we go through this series. And part of the series will take a look at things like writing tests, more advanced data structures, how to use external packages, how to build our own APIs, how to run HTTP connections to other APIs to fetch data, working with different data structures, connecting to databases, and more. So remember to like and subscribe if you like this video, and stay tuned for the next one. And if you want to support the channel even further, be sure to check the link down below to become a member. Also check the community page down below so you can join the community. And as always, thanks for watching, and until next time, peace.